So see now next numerical is a parallel plate capacitor with air between the plates has a capacitance of 10 picofarad. The capacitance, if the distance between the plates is reduced by half and the space between them is filled with the substance of dielectric constant 4 is. Okay. So what they are saying, see here the question is can be divided into the two parts. So first part of the question is a parallel plate capacitor with air between the plates. For air, the dielectric constant K is equal to 1. Okay. So plates has a capacitance of 10 picofarad. So C is equal to, they have given 10 picofarad. Okay. So or it can also be written as C is equal to A epsilon naught divided by D. Its value is 10 picofarad. See, pico means 10 to the power of minus 12. Okay. So next, the capacitance, if the distance between the plates is reduced by half. Here again they are asking the capacitance. Okay, C dash. So I will consider this as C dash. Okay. So if the distance between the plates is reduced by half, here they are reducing the distance to the half. Okay. So distance is half and the space between them is filled with a dielectric constant, and the space between them with a dielectric constant and its value is 4. Okay. So see now, see capacitance of the parallel plates is given by C is equal to A epsilon naught divided by D. Okay. So here we have taken as C, instead of C we have taken as C dash. So C dash becomes A epsilon naught by D, but D here we have taken as D by 2, right? And it is filled with the dielectric constant, that's why I will replace with the K. Okay. So now C dash is equal to denominator of denominator becomes numerator. Okay. So that's why it will become K into 2 times of A epsilon naught divided by D. Okay. So C dash is equal to, what is K value? So K value is 4. So 4 into 2 into, and A epsilon naught value means it can be written as C. So that is equal to 4 into 2 into, what is C value they have given? So C value they have given as 10. Okay. So here 10 2s are 20, 24s are 24s are, so we'll get 80. Okay. So 80 picofarad is the required solution. Okay. So see now next numerical is a parallel plate capacitor of capacitance 5 microfarad and plate separation is 6 centimeter and it is connected to the 1 volt battery and it is charged. A dielectric of dielectric constant 4 and the thickness is 4 centimeter is introduced between the plates of the capacitor. The additional charge that flows into the capacitor from the batteries. Okay. So here we need to calculate the additional charge. Okay. So see, this question can be split into the two parts. So what is the first part? They are saying a parallel plate capacitor of capacitance. Here they have given the parallel plate capacitor with a capacitance that is C is 5 microfarad. Okay. And plate separation means the distance between the two plates. So that is D is equal to, so 6 centimeter. It is connected to the 1 volt battery and it is connected to the 1 volt battery. So voltage is 1 volt. So and it is charged. Okay. But charge value they have not given. That's why we need to calculate Q value. Q is equal to question mark. Okay. And a dielectric of dielectric constant 4 and the thickness is 4 centimeter is introduced between the plates of the capacitor. So here they are introducing the dielectric material having the dielectric constants. So it is given by K is equal to 4 and the thickness is also, so T is equal to 4 centimeter only, and is introduced between the plates of the capacitor here. So this one it will gives the additional charge. So we need to, additional charge flows with the capacitor from the battery and we need to calculate the additional charge. Okay. So here I have taken already Q. So the additional charges I will mention by Q dash. Okay. I need to calculate Q as well as Q dash. Okay. So what is the formula for calculating the Q? So C is equal to Q divided by V. I want Q. Q becomes C into V. So that is, what is C value? So 5 microfarad. So into voltage is 1. So that's why Q becomes 5 micro coulomb. Okay na. So SI unit of charge is coulomb. Okay. So this is the first part. So second part, in order to calculate the Q dash, so here they are introducing the dielectric of the dielectric constant. So that's why the dielectric medium, if the dielectric medium is introduced between the plates, so the formula becomes C is equal to A epsilon naught divided by D minus T minus T divided by K. Okay. So this is the expression for the parallel plate capacitor with the dielectric medium. Okay. See here, so we know the expression for C is equal to A epsilon naught by D. Here so there is an absence of D. So that's why I will divide both numerator and denominator by D. Okay. So what it will become, C is equal to A epsilon naught divided by D. So divided by, so 1 minus T minus T divided by K whole divided by D. Okay. So what is A epsilon naught by D? A epsilon naught by D means C. So divided by 1 minus, what is T value? So T value is 4. Again 4 minus 4 divided by 4 whole divided by D value is 6. Okay. Now simplify this one. C is equal to, what is C value? So C value is 5 divided by 1 minus 4 minus 1 divided by 6. Okay. 4 by 4 means 1. Now here it will become C is equal to 5 divided by 1 minus 4 minus 1 is 3 divided by 6. Okay. So C is equal to 5 divided by, here 6 ones are 6 minus 3 divided by 6, that is C is equal to 5 divided by, so what it will become, 6 minus 3 is 3 divided by 6, here 3 ones are 3 twos are 6, so denominator of denominator becomes numerator, here it will becomes 2 into 5, so that is equal to 10 microfarad. Okay, here we got the C value, but we need to calculate Q dash value. So that's why Q dash becomes, so Q dash becomes C into V. Here now I need to substitute this C value. So that is 10 microfarad into voltage is 1 volt. So additional charge becomes 10 microcoulomb. Okay. So Q dash become 10 microcoulomb. So see now next numerical is, a parallel plate A capacitor has a capacitance C. When it is half filled with the dielectric of the dielectric constant phi, the percentage increase in the capacitance will be. Okay. So what they are given? So initially they have given the parallel plate capacitor with air between the plates has a capacitance C. When it is half filled with the dielectric of the dielectric constant, here they are filling the dielectric material having the dielectric constant K is equal to phi. Okay. So the percentage increase, so in the capacitance will be. Okay. So here, see here, this one I will consider as C1 and this is C2. So initially the air between the plates is given by C1 is equal to A epsilon naught divided by D. Okay. See here, so if the total distance is D by 2 means, so this distance become D by 2, similarly this is also becomes D by 2. Okay. So here this will become D by 2, denominator of denominator becomes numerator, C1 is equal to 2 A epsilon naught divided by D. Okay, so this is initial case C1. Similarly, C2 is equal to, so here K times. So K times means they are introducing the dielectric medium having the dielectric constant K. Okay, so K A epsilon naught divided by D by 2. Okay, so here C2 is equal to, what is K value? That is 5. Denominator of denominator becomes numerator, 5 into 2 A epsilon naught divided by D. Okay, so it will become C2 is equal to 10 A epsilon naught divided by D. Okay, see here, so this both are in series. So this parallel plate capacitors are both are in series. So I can apply series formula. What is series formula? 1 by C is equal to 1 by C1 plus 1 divided by C2. Okay, now simplify this one. 1 by C is equal to 1 by, what is C1 value? So C1 value is 2 A epsilon naught divided by D. So plus 1 divided by 10 A epsilon naught divided by D. Okay, so here again denominator of denominator becomes numerator, that is 1 by C is equal to D divided by 2A epsilon naught plus D divided by 10A epsilon naught. Okay, so here for the simplicity, so I will take this C as C dash. Okay, so now 1 by C dash is becomes, so here D divided by A epsilon naught is common. So D divided by A epsilon naught is common and remaining term is 1 by 2 plus 1 by 10. Okay, so that is 1 by C dash is equal to D divided by A epsilon naught. So what is the LCM for 10 and 2? So if you take the LCM for 10 and 2, so it will become 10. Okay, so 2 2 5s are 10, 2 1s are and 5. So 2 5s are 10. Okay. So LCM is 10, and if you divide, so 1 by 2 divided by 10, denominator becomes numerator. So 10 by 2, that is 5. So again here, so 1 by 10 divided by 10, denominator becomes numerator, 10 by 10, that will becomes 1. Okay. So here we will get, so 5 plus 1. Okay. So this one is, this is 5 plus 1, so that is equal to 6 divided by 10. Okay. So see here, this one is 1 by c dash. I need to calculate c dash. So take the reciprocal. C dash becomes, here numerator becomes denominator, denominator becomes numerator. So here we will get a epsilon naught divided by d. So and 10 divided by 6. Here 2 5s are 10, 2 3s are 6, that is 5 divided by 3. Okay. So c dash becomes 5 divided by 3. So now I need to calculate the percentage increase. So percentage increase is given by the formula. Percentage increase is equal to c dash minus c divided by c into 100. Okay. So this is the formula. Now substitute here. So what is c dash? So c dash is, so here I have left it a epsilon divided by d, right? So here, so c dash means 5 by 3 a epsilon naught divided by d minus a epsilon naught divided by d. C means a epsilon naught by d divided by a epsilon divided by d into 100. Okay. So that is equal to, so if you divide this one, so this term is for this term also and this term also, it will become 5 by 3 minus 1. Okay. So into 100. So now cross multiply, 5 minus 3 divided by 3 into 100. So 5 minus 3 means it is 2 divided by 3 into 100. So 2 divided by 3 into 100 means you will get approximately 66.6%. Okay. So this is the required answer.